Greetings. Let's solve Leetcode 2182, construct string with repeat limit. You are given a string S and an integer repeat limit. Construct a new string repeat limited string using the characters of S such that no letter appears more than repeat limit times in a row. You do not have to use all characters from S. Return the lexicographically largest repeat limited string possible. A string A is lexicographically larger than a string B if in the first position where A and B differ, string A has a letter that appears later in the alphabet than the corresponding letter in B. If the first minimum characters do not differ, then the longer string is the lexicographically larger one. All right, so let's kind of go over that for using this example here. So they want us to make, given this string, they want us to make it as big as possible, meaning in lexicographical order. And we can't have more than a certain character stacked more than 3 times together, a repeat limit. So in this scenario, it makes most sense to use the biggest characters or largest characters in ASCII. So the largest letters are Z, so there's 2 of them. So 2 is less than 3, so we're less than or equal to 3, so we're fine. In the next letter, for the next letter, we have 4 C's, but we can only use 3 of them as indicated by the problem, so they stack 3 of them together. And temporarily, they use the next available largest letter, which happens to be A. So they insert an A there, and then they revert back to the biggest letter that we were using at the previously. So they go back to using C. So this is the answer. I think that makes sense. And here we go. It's another example and the same idea. So in this case, we're only allowed to stack 2 letters together. So again, use the biggest letters. Here we have 3 B's, but we can only use 2 of them at the moment. So we use 2 B's, and then we insert A temporarily, go back to our biggest letter, B, and there's only 1 B left at that moment, so we insert it. Then we go to the next available largest letter, which is A, and now there are only 2 left because 1 was inserted earlier here. And this would be the returned result. Okay, so I think that's straightforward enough. Depending on how long this video gets, I think I will try to present 3 solutions for you. One uses a dictionary. One uses a min heap, minimum heap, and the last uses a list. Okay, so if we have enough time, I don't want this video to get too long, but if we have enough time, we'll go over all 3 of them. I think they all have the same idea. And the idea is to always use the biggest letter. And temporarily, if needed, use the very next letter, then go back to the biggest letter. Okay, so using this dictionary approach here, let's use that here. What we'll do is we will get frequencies for each letter. And then we will what we'll do is we will keep an index of the current largest letter. Now, when I say letter, in order to make things convenient, we'll use the ASCII numeric value for that letter. So keep in mind that the letter A in ASCII is the numeric value 97, and for Z the numeric value is 122. And we're told that we're only going to be using English lowercase letters. I think here somewhere. Yes. So we'll be using these values. So what we'll do is we'll always start off, we'll say our current will be we'll start it off at 22, and then if we don't have the letter Z, which is 122, then we decrement to 121. If we have no letter Y, we just keep decrementing until we find a letter. Okay, and then suppose we have something like this: 4 C's and 3 A's. And suppose K equals 2. That's the repeat limit. Repeat limit is 2. So in this case, we would have to use 2. Just suppose our current is 97, 98, 99. So what we would do is we'd say, okay, we can use 2 of you, so 2 C's. We can use 2 letters of current. But then we need to temporarily jump to the next lowest available letter. So if we're 99, the next lowest one will be 98, which is the letter B. And the letter B is not available in this string, so we would have to go down again to 97. So I wanted to make that point. So we'll always try to find the next letter available, and we'll be using a while loop for that. And that's pretty much it. I think a lot of it will become clear once we start coding it. Okay, let's start coding it. So the first thing is, remember we want to get the frequencies. So let's get the frequencies. So we'll say frequencies will equal default dict, default dict, and this will be an default dict. Yes, that's fine. And then we'll loop through all the letters. So for C and S, we'll say frequency of. Now, in order to make it convenient, we don't want to store the letter here. We want to store the ordinal. We want to store this number. So we'll do that. So did I spell this right? Default dict. Default dict. I think so. So we'll take the ordinal of the letter. So that'll give us the numeric value. So we'll say the ordinal of C plus equals 1. Now some people, they subtract the ordinal of A here, something like this. They do something like ordinal of A. You don't need to. You could, but we're gonna be smart, and we're gonna remember that we're gonna know this. So we'll just keep that in mind. So this C, for every character in S, we're gonna store the ordinal of that and just keep adding to the frequency count. Okay, and what I'm going to do now, just for the hell of it, I'm just going to print frequency just so we get a look at it. And in order for us not to get an error, I'm just going to return S. So let's just get a look of what that looks like. Okay, great. So here we have, so here's 4 C's, so 94 C's, 2 Z's, 122, and 1A. Okay, great. And now let's move on. So we don't know, we'll always set the current index just to the maximum possible, which is a Z. So that's going to be 122. And we'll also set the result equal to a list. Now, what we'll be doing is we'll be looping through the string, and every time we find a letter that we can use, we'll add it to the result. Temporarily, I'm going to do this. So at the end, I know I want to join result. So I'm just going to do that right now. Excuse me while I die. Where are we at? Oh yeah. So we'll do this while current is greater than or equal to. So this is the letter Z. We want to keep going down all the way down until the lowest letter possible would be A, which is 97. After that, we stop. So now, suppose there are no letter Z's. So what we want to do is go to the next letter. So we'll do something like this. So if frequency of current equals 0, well, we need to go down to the next letter. So current minus equals 1, then we continue. So we just go back around. Okay, great. Now, if we've gotten past this point, that means there are letters at that ordinal. So what we'll do is we want to figure out how many letters we can use. So in this case, remember, we have 4 letters of C available. This is just an example, but we're only allowed 2. So we would take the minimum of them. So we would take the minimum of 2 and 4. But suppose it was the other way around. Suppose we're allowed to use 12 letters. Well, we don't have 12 letters available. So we would take the minimum, which is 4, because we have 4 C's here. 4 C's. So just depending on which is the least, we'll use that. And I'll just set that equal to M. So M will equal the minimum of K, which is, I call that the repeat limit. I just changed it. I don't want to write repeat limit. And frequency of current. So those are the numbers, those are the number of letters we have available to use. Now, what do we do with all those letters? We append those letters to result. So which letter do we append? So right now current is just, that's the ordinal. We want to convert that to back to its letter. So we say char of current. Now that's one letter, but we want to, remember we can use M of them. So we say that times M. Times M. Okay, great. Okay. So that means we've used, in this case, when this was 2, we've used 2 of the letters. That means we only have 2 more available. So we need to adjust our frequency count. So frequency of current minus equal M, because that's how many we used. Now, suppose, as in that case, we would have 2 letters remaining. Remember, we have 2 letters, we used 2, we have 2 remaining. So temporarily, we need to use the next letter available. So let's do that. So we check if frequency of current is greater than 0, that means we have more letters available. Then we jump to the next letter. So next would equal current minus 1. But now we have the same situation as before. What if there isn't a next letter? Meaning, like, we're at C currently, right? And the next letter would be B. So what we'll need to do is we'll need a loop until we find a letter. So let's do that. So we'll say while next is greater than or equal to 97, because we don't want the letters to go below A, right? Because we can't use anything else. We're only allowed certain letters. And there is a letter, so we'll keep looping it. While there's no letters, we'll keep looping. So if there's no letters, we keep trying the next one. So if there's no letters, we check if there's no letters. We try the next one, the next one, the next one until we find a letter. However, though, suppose we've gone past, like beyond what we're supposed to. Then we need to just break out of this loop. So if next is less than 97, we just break. Otherwise, we found a letter. So let's use that letter. So we'll say result dot append, and we only need one of them. So let's use that letter. So we convert it to a character, and then remember though, we've used one of these letters now. So we've used one of the A's to break this up. So we would have CCA, CCAA. So since we use one of them, we need to adjust the frequency. So let's go back and adjust the frequency of the next letter. So frequency of next minus equals 1, because we've used one of them. Okay. And I think that's it. Let's check it. Okay, great. Looks good. And let's submit it. Okay, so that works. It works fine. Okay, off to the next solution. So the next solution is going to be using a min heap. So let's see what we can do here. Okay, for the min heap. Now remember what we did here is for the previous problem we used this current variable to store the biggest value. And this, using the min heap, we'll use a min heap to store the minimum value. So let's see how that goes. All right. So let's just remove all of this. Okay, so let's use a heap. So what we'll do is let's create our heap. So we'll call this Q. Well, let's do this first. Let's say let's get the counts. So I'm gonna use counter here, counter of S. Now this will give us, for each letter we'll get the counts, and then we'll get dot items. And I'll print out what this looks like, and then we'll do for K and V in this, and then we'll do something like we'll set this as a tuple, and we'll set the ordinal of, so this is the letter, so I'll just say K, and this is VV, and we'll set this to Q, and I'll print this out so we know what this looks like. Return S, and let's print Q, and I'll go over what just happened there. Okay, so notice how this is similar as before. We have 99, which is the letter C. There's 4 of them, 2 letter Z's and 1 letter A. But now we have this in a tuple. Okay, so there's a couple issues here. So remember, the heap in Python is actually a min heap. So we need to make this a negative in order to get the largest. Now by doing this becomes, in a way, becomes a little trick to use a min heap to make it a max heap. Now this will give us the largest letter. Okay. And now we need to heapify it. Heapify Q, or Q. All right. Sorry, I was choking. Okay, so then let's go through our heap. So while Q. So let's pop off the value from our heap. So then we'd have O and C will equal heap pop Q. Now let's remember what this is. So this is the negative of the ordinal, and then this is the count. So what we want to do is we want to get, remember as before, I erased it, but we used the minimum of the count and the repeat limit. We need to do the same thing over here. So we want to say M equals the minimum of K and this count, which is right there. So this is the count, like how many letters we have available, and K is the repeat limit. And then we do exactly the same as before. We say, okay, we'll say result.append. Now the letter, So the letter, well, what's the letter? We have the negative ordinal here. So we need to change it to a char, but then say negative of O, and then times M. I hope this makes sense. And that's why I put this comment here. So this O is the ordinal, but it's the negative of it. Remember we put the negative here? And then, so now we need to convert it back to its normal ASCII numeric value. Okay, and then as before, we need to, oh, sorry. Do we need to adjust our, no, we don't. No, we don't need to adjust our frequency count because remember last time we're not using that approach anymore. But we do have the same issue as before. What if there are more letters though? So my point is, what if C is greater than M? So remember we had 4 C's available, and we used a minimum. So in this case, the minimum of 4 and 2 is 2. So we subtract them. So if there's still more letters than M, that means, sorry, and there's still elements on the queue, we need to adjust for it. Remember, so we need to go find the next one. So we need to pop again. So we can actually use this again. We need to pop again. Okay. But I'm going to call this the ordinal of the next, and I'm going to call this count of next, just to make it easier for us to distinguish the variables. So then we add one letter. So we add one letter. So result dot append one letter again. So we say char of negative O next. Okay, great. Okay. So now we have a little bit of a question mark. So we don't know how many letters are left, but if there's more than one, so if the count of next minus 1 is greater than 0, then we need to put it back onto the heap. So heap push Q O next. So remember, this is still the negative, so I don't need to put another negative on it. And then the count minus M. So M was the amount that I used. So M. Okay, good. Sorry, not that. Sorry, count minus 1. So we used, sorry, C next minus 1. I totally apologize. So this is the next variable, sorry, the next like character that I had available, and I'm using one of them. Okay, and then we go back, then we still need to adjust the, sorry, I think that's it. Sorry. So here we have more letters available. So that means we still need to put them back on. So we need to put heap push Q O and then C minus M. Because remember, we used M of those C, so C minus M. And this is the same negative ordinal, and we put it back. So remember though, if C was 0, we wouldn't need to do any of this. We wouldn't need to put back more letters or use the next letter. We could just jump to the very next one. So again, this is all contingent upon there being more letters of that certain type. Okay, I hope that makes sense. And I think that's it. So what would it be? Dot join result. Let's check it. Oh. Okay. Result equals. Okay, great. Let's submit it. Okay, that's better. And then the last one. We're going to use the list. Okay, so let's move this out of the way. Okay, the list. Almost the same exact scenario. List. What we're going to do is we're going we're gonna sort them, and that'll, and then go from the back. So we will count letters, count frequent. We will get frequency count, frequency count, and sort them by the frequency, and then and remember, when we sort something, it automatically sorts something like this. It would be something like A, B. It typically sorts it in from minimum in ascending order. And so what we'll be doing is we'll be popping off back of list. Okay, so let's go over how that looks. And then everything else is exactly the same as the other problems. So let's get rid of all this. Okay, so let's say let's start this off here. So we'll say maybe so we'll say this Q equals sorted, and we'll get counter again. So counter of S, and we'll say just dot items. And then we'll look at it right now. So see what it looks like. So in order to just get past this, we'll just say return S so we don't get an error. And then we'll print what Q looks like. So print Q. Okay, so there's 1A, C, and so this automatically sorts it. Sorted, remember, sorts by from minimum to maximum in terms of letters. So we'll always pop off the back. And then, as you can see, that will give us the lexicographically largest string. Okay, so let's continue on. So what we'll do is we'll say, okay, and I'm still going to use this. I'll use result again. And let's do as we did before, just return join. I think that works. Okay. So then we'll say while Q. And then remember, like we did, or like I showed, we'll say something like, so we'll pop from the back. This will be the letter, and this will be the count. So we'll just say maybe, we'll just make it easier. We'll just say letter count equals, what do we want to call this? Q dot pop, that's from the back. Okay. And then we want to say M, so that's going to be the minimum of K and the count. Okay. And then as before, we can add this like that many letters to result. So we'll say, okay, result dot append. Now since this is the letter in raw form, we can just use it. So letter times M. Okay. And then we want to adjust our count. So our count becomes count minus equals M. So now remember, this is similar to the problem we had before. So if count is, well, greater than 0, then remember we need to temporarily use the next letter. Okay, so let's do that. So assuming that there are letters still in, so let's go over what that means real quickly. So what if we're here? So we need to make sure that there's still letters in the list or the queue. So we need to do that. So we'll say if Q, then let's get the next letter. So we'll call this maybe just, it's fine. We'll just do this next letter. and next count equals q.pop. Okay, so notice how this is the same theme for all of the approaches, for all of the solutions. Okay, so what we can do is add this to result dot append next letter, and then we need to adjust our count. So next count minus equals 1. Okay, now let's think of something now. So if next count is greater than 0, that means there's still letters of the next one. We need to put it back onto the list, just like we did for the queue. So we used 1, but if there's still some remaining, we need to put it back on the list. So we need to say, okay, q.append. Now what do we put back on the list? We put that letter on. So next letter, and then the new count, the next count. So let's take this off. Where is this at? Sorry, I spelled this wrong. Okay. Okay, great. Now one more last thing. So remember, let's just go back here. So suppose there was like 6 letters here, and we could only use 3 of them. So we would use 3 of them, and then we would use one of these. Remember, we popped this off and popped out of. So we need to put this one back on, and then we need to put the Z's back on. So I hope that makes sense. So if there's still more letters, remember we popped it, but we need to put it back on. So we made sure that if we added the next letter afterwards, we have to take care of that first, and then we can basically do the same thing here. But we need to use it for these guys, for this stuff. So that goes back to the original letter and the updated count. So notice how I updated the count here. Okay, and I think that's enough. I think that's it. The problems were very similar. Well, let's make sure it works. Okay, great. Let's submit it. Okay, looks nice. Okay, so all of the problems were similar, like in theme, but they were just like a slight variation. I really thought it was very beneficial to see the different approaches, and that's why I thought, like, I knew it would be a long video. I still don't know how long it is. This may be my longest video, but I thought it was very beneficial to see all of the different approaches and how there's a slight variation in it. And I thought it would be like an excellent learning experience for both you and myself. Okay, if you found this video helpful or educational, please consider liking or subscribing. I apologize if I made any mistakes, but I hope in the end that I corrected them. If there's still any confusion or questions, or feel free to comment, and I will return or reply. All right, gentlemen and ladies and gentlemen, have a wonderful day. Take care of yourselves.